It's very important to talk about a 4G EPC before we talk about 5G core. So if you take a 4G EPC network, you basically will have something known as a MME. So MME stand for Mobility Management Entity. So as the name suggests, one of the use case for MME is for the mobility management. The other will be session management, and the third will be a user authentication, right? Say user once connects to a eNode B, there will be a signaling traffic. So the eNode B will send the signaling traffic towards the MME. So MME is responsible for the mobility management of a UE if we move from one eNode B to the another eNode B, and also for session management and also authorizing a user, a UE towards the EPC network. So MME will go and check what you call as HSS. HSS stands for Home Subscriber System, and it will be the HSS uh, role to basically give the subscription profile to the MME and also generate the authentication vectors that MME can use. So HSS will basically have the a database where it will have all the subscriptions detail of a UE. So it will basically have the details like whether it is a postpaid subscriber or a prepaid subscriber, and will pass this all informations towards the MME. So it will be the MME's duty to select a S gateway for the UE traffic, right? So S gateway stands for serving gateway, which basically enable the communication or the data path for a for a UE towards the uh, EPC network, right? So then you will have a data path that has been established between an S gateway and an E node B, where the traffic for the data path will flow. So S gateway will be the first entry point for the UE towards the EPC for the data traffic. And it S gateway will basically have two roles. One is for route the packet towards what we call as P gateway, and for local mobility anchor, right? So the S gateway routes the traffic towards the P gateway, and it will be from the P gateway that the traffic goes outside the EPC network. So P gateway will be mainly responsible for route the traffic towards an external network like an internet, apply a QoS policy with the help of PCFR. It basically check the database where the user information is saved and apply the policies towards the P gateway, and P gateway make sure that the policy is applied to the data traffic with the help of QoS, right? And P gateway is also responsible for assigning the IP address towards the UE. So for an example, this UE, the user equipment, which contains the SIM card and the mobile of a user, can traverse from one eNode B to the another eNode B, right? During this time, the session should still be managed. Like the user still should have the connectivity towards the internet, even though he moved from one eNode B to the another eNode B. So for that, the IP address is basically assigned by the P gateway, which means the IP will be still at the P gateway external interface where they will be doing an acting, but then you will have a GTP tunnel, right? GTPU tunnel from your P gateway towards your eNode B. So there will be basically two tunnels, one from P gateway to S gateway, and from S gateway to the eNode B, so that the user traffic once it hit the P gateway, then will be encapsulated and will be traversed over the tunnel uh, across your EPC and will be given to the E node B, and from there it will be sent towards the UE. So your UE will have an IP address that is corresponding to a P gateway IP address and can traverse through different E node B without changing the IP address, right? So you don't have to change the IP address once it goes from one E node B to the other E node B because the help of P gateway. So when you take an EPC network, These are the main component that you will have in an EPC network, right? You will have an MME, a HSS, a S gateway, a P gateway, and a PCRF. So let's look at in the next videos how this corresponds to a 5G core network.